What's up, everybody? Welcome to the channel. I know I made a little intro video the other day just to start things out, but this is the first real post. We're actually going to get into some of the material. I figured a great place to start would be simple derivatives for those of you taking calculus, whether that's AP in high school or intro in college. And when I say simple, I'm referring specifically to the power rule derivative, which is what you would learn on day one of the unit, pretty much. And so let's just dive into a few examples. Simple power rule derivatives really just have a few steps to them. In this first example where you see the function f of x equal to 3x to the 7th power, all we see is a coefficient number of 3 times the variable of x, and it's raised to a power of 7. And as the power rule's name suggests, we're going to be doing a lot of stuff with the power or the exponent up there, that's 7. And so in your first step, what you have to do when you say, okay, I'm going to take the derivative of this function, first of all, you have to label the f of x in a different way. You have to call it f prime of x, and the prime is just an apostrophe symbol that you put in between the f and the x, and so I'm going to go ahead and do that here. And then what you do with the exponent is you indicate what your starting one is, okay? So ours is 7 at the beginning, and what you then have to do is just a few things, right? You multiply it down to the front, so you're multiplying out front by the 3 that's already written there. And then you always do this next part. You subtract 1 from that original exponent of 7, right? So effectively, you're looking at 7 times 3 out front, and then you have x raised to the new exponent, or what will become the new exponent of 7 minus 1, okay? And so that gives you a final derivative answer of 21 times x to the 6th power. So in that example, having the 3 out front made it pretty clear of what to multiply the 7 by when we brought it down. But what if there's no coefficient in front at the beginning? For example, let's just say we had this new function g of x equal to x to the 5th power. So in this case, as you can tell, we don't have a number out front like we did last time, like the 3 that we had in our previous problem. And so a lot of people wonder, what would we do when we inevitably bring the exponent down? And so let's go ahead and try to do power rule. Okay, so basically, we identify the original exponent, which is 5, and we bring that out front. And then what we realize is that actually the 5 is multiplying by a 1 out there, because when there was no prior coefficient written out front, we just assume it to be 1. So if you ever see an x alone, you just assume 1x, right? And so we have 5 times 1 out front now, and then again, we, as always, subtract 1 from the original exponent, and so our exponent will be whatever 5 minus 1 is. This all gives us a final answer of 5 times x to the 4th. So nothing too bad about that, but what if this time the exponent is invisible instead of the coefficient? This particular type of example has an extraordinary shortcut that you can think through, but I'm going to prove to you that it works using the power rule. And so look at the function here, h of x equals 13x. Okay, so I was just saying how the exponent this time is invisible, and what I mean by that is that the exponent, when you just have an ordinary variable x, the exponent is technically 1, right? Just how we don't write 1 as a coefficient typically, we also typically don't write 1 as an exponent. Okay, so we can think of this as 13x to the 1st power. And what do? We just follow our normal steps. So we take our original exponent of 1, multiply that down by the 13, and next we say, okay, whatever the original exponent was of 1 minus 1, right? We always do that. This will give us, for the time being, 13x to the 0th power. Okay, so when you have a 0 power, anything that's raised to a 0 power directly gets turned into the number 1, right? So the exponent of 0 goes away, whatever was raised to the exponent of 0 goes away, you just get the number 1 left over multiplied, right? So back to the example, 13 is technically not raised to the 0 power itself, but the x part is. And so whereas we used to have a 13 times x to the 0, we can say now that we have a 13 times 1. And luckily for us, that just boils down to a final answer of 13. Okay, so if you notice, the 13x function had a derivative of 13, right? And we could say the same for a function of 20x, for example. The derivative of 20x would be 20, or the derivative of 7x would be 7. So if you notice the pattern that if you ever have a coefficient times an x variable raised to a 1st power, your derivative of that function will just be the coefficient number. So the next question is, what about standalone numbers? like 5 or like 11 or something like pi. Remember, pi is just an ordinary number. So what happens to those when we take the derivative? Ordinary numbers are also called constants. And so let's just say we have a constant function, j of x, that's equal to the constant of 5, right? So this is an ordinary number. Whatever you take the derivative of a number, no matter what the number is, no matter how big or small, it's just 0. So j prime of x is equal to 0. And so what about the derivative of this function k of x that's set equal to pi? Well, again, pi looks like some special symbol, but we got to remember it's just a simple number close in numerical value to 3.14. And when we take the derivative of any number, doesn't matter whether it's a decimal or irrational or rational, doesn't matter at all. K prime of x is going to be 0, just like the derivative of any other number would be equal to 0. So that's super easy, right? So the derivative of any number is equal to 0, no problem. However, your teachers can still trick you with this. I guarantee you, look at this next example. In the function m of x equals pi cubed, we notice there's an exponent, and we've been dealing with a lot of exponents today when we've taken power rule derivatives. Okay, but what we have to remember is that pi is just a number. It's not a variable being raised to a power. It's a number being raised to a power. So a lot of you may dive into this and think, oh, look, power rule, we gotta bring the 3 down. That's our original exponent, multiply by that out front, minus 1 from the 3 in the original exponent, and it equals 3 pi squared, right? Wrong. Pi is just a number. We have to treat it like just a number, and we have to take the derivative as if it was just a number, right? So pi cubed is essentially something close to 3.14 cubed, which at the end of the day is just a number. And what's the derivative of any number? 0. So you might have guessed it at this point, m prime of x is equal to 0. So do not be fooled by that. Okay, so those were kind of the simple power rule derivative examples, and they definitely get more complicated. I'll put those on future posts. But yeah, hopefully this all helped, and see you on the next one.